Morning. Hello, class. Today I'd like to look at optics. Obviously, we're starting with optics. I'd like to focus in on the law of reflection. So we're actually going to start about halfway through that note. The first half of that note covers a lot of terms and definitions that you can read for yourself. So with regards to the law of reflection, we do need to make sure we understand that there are two specific angles that we are going to be looking at: the angle of incidence, which is the angle between the incident ray and the normal, and the angle of reflection, which is the angle between the reflected ray and the normal. So if we look at a diagram here, we can see lots of different things from this. So the first that we want to make sure we understand is that the reflecting surface, or this area here, is reflecting the mirror that's being represented. The reflecting surface is that black line that's showing the light bouncing or reflecting off. Okay, so we have our incident ray, which is this ray coming in, again shown with a straight line with the arrow showing the direction of that incident ray. So the light coming in, when it hits that reflective surface, that's where we call the point of incidence, where it strikes that surface, and then the ray coming out is our reflected ray. Again, we're using a straight line and an arrow to show the direction that it's bouncing. The line that we see perpendicular to the mirror, so this line here that comes straight down perpendicular to our mirror, so that means that it's a 90-degree angle here. That is our normal. Okay, and so the angle that we are getting between the incident ray and the normal, that's going to be our angle of incidence. Okay, and again, it's represented with that angle symbol, and a little I. And so then our reflective ray and our normal, this space in here is going to be represented by the angle of reflection, and again represented with the angle symbol and that lowercase r. So moving on, the law of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. So again, looking at our diagram, we have our incident ray coming in, we have our reflected ray moving out, we have our angle of incidence and our angle of reflection. The law states that they are going to be equal if obviously everything is done right. Okay, now with that being said, the law also means or is telling us that the incident ray, the reflected ray, and the normal all lie on the same plane. So again, we're not looking at 3D or anything like that. So all lie on the same plane. So if we look at the following example, right? So you've got your diagram in front of you. If you need to pause to answer the questions, that would be awesome. So going through this, what would the angle of reflection be for an angle of incidence of 28 degrees? So again, if we know that the angle of incidence is 28 degrees, then what will the angle of reflection be? Well, we know then, based on the law of reflection, that this angle will also be 28 degrees. Okay, so that answer would be 28 degrees. Question 2 asks, what would the angle of reflection be if the incident ray was 35 degrees from the reflecting mirror surface? So again, now it's not telling us one of the angles, it's telling us that from the reflective surface, so from this surface on towards that incident ray, it's 35 degrees. Okay, now based on everything we know, the normal is perpendicular. We know that this is going to equal 90 degrees. And so 90 minus 35 is going to leave us with an angle of 55 degrees. And therefore, it's asking us for the angle of reflection. And if we know the angle of incidence is 55 degrees, then we know the angle of reflection will also be 55 degrees. Okay, so the last part of this note talks about specular reflection and diffuse reflection. Specular reflection is reflection of light off of a smooth or shiny surface, such as a plane mirror, a flat piece of aluminum foil, or even calm water. And it's telling you that all the angles of incidence for all of those parallel incident rays are going to be identical. Whereas diffuse reflection is going to happen off of an irregular or dull surface, a piece of paper, crumpled aluminum foil, rough water. And so as a result, you're not going to get those parallel lines, those parallel angles of incidences, and the reflected rays are going to bounce off in many different directions. So based on the diagram we have, our specular reflection, or our smooth surface, our smooth surface here, shows you that all of these incident rays here are going to be equal, and as a result we end up with parallel lines. We see a very clear image. Whereas here, because the surface is smooth, we end up getting those reflected rays going off in many different directions, and as a result we don't see a reflection or a very neat reflection from that. Okay, hopefully this helps. Thank you very much.